we were deriving this, so let's continue now. Okay, so what we were doing, right, we are multiplying this by this, okay, operating this on that, right. So it is going to be del 2 z v of y, okay, so this is v of y, right, minus del 2x v of y, minus and minus is plus del x del y v of x, plus z cap, right. So there will be a plus sign over there, okay. Now it is going to be del x del z vx minus del 2x vz minus del 2y vz plus del y del z vy. Okay, so we will take these terms, let's see, okay, so we will take this term out, and this, and no, not these terms, okay, let's do one thing, let's expand the RHS as well, so that we can compare all the terms in both LHS and RHS. Let's say this is 1, let's say, and this is 2. So we will take this 1, which is, let's write it here, we'll take this 1, which is del the gradient of this divergence, right. So what it is going to be, we have already calculated it, so it is this term, right. So we'll just copy it, right. Now let's take the second term. Second term is the is del square v, is del square v, so it is going to be del 2 x, this is v, del 2 okay, so del square v is we have already calculated it, we know where is this del 2 square, okay, so actually this del 2 square v, this is not del 2 square v, because this is a t is a scalar quantity, and where here we have this v as a vector quantity, right. So what is the final values of this term, let's see this, okay. First of all, which is it is equal to the del dot del acting on v, so it is going to be, first of all, del dot del is going to be del square plus del square y del square z, right, acting on vx x cap plus vy y cap plus vz z cap, right. So the x component is gonna be, right, so x component is gonna be del 2x vx plus del 2y vx plus del 2z vx. Similarly, y component is gonna be del 2x vy plus del 2y vy plus del 2z vz, plus z component is gonna be del 2z vx plus del 2z vy plus del 2z vz, right. So we have these many terms. If we only talk about this x component of this RHS side, so what we're gonna have is these terms. Okay, so if we talk as the x component, so it is going to be these terms. So this is the first term, and the second term is right. And here for the x component for the LHS, we have this term, right. So this is LHS. And one thing that I forgot over here, it is the minus sign will be here, because as you can see in the formula we have minus sign in the front of this second term, right? So we'll have minus sign over there, and all the plus term will be minus, and minus term will be plus. Right. So it is going to be minus sign, right? So we can match these two terms, we can also match these terms, we can also match this term, we can also match this term, and these two terms are left, and it is going to be cancelled out anyway, right? So we have LHS equal to RHS for the x component of these of this equation, and similarly we can, if we just extract out this y component of both the LHS and RHS, let's do it first. So yes, so this is the y component, which is the LHS. Let's do it for the y component for the RHS, right? This is the y component for the RHS, which is the first term. Now the second term is going to be this one, right? Now we will compare ZY. Okay, so YZ, so these are the same terms, del square x and del square z. So we're gonna have del square z minus del square z, right? Minus del square x minus del square x, del x del y, del x del y del x. Okay, and two terms is going to cancel out, right? So what are those terms? Okay, so these two terms is going to cancel out, yes. Other are just matching with the same. Okay, similarly we can extract when we extract out the z component, right, we'll also see z component, so it is going to match with these z component. You can just check on your own.